Okay, so now we look at what we call the components of a vector. So earlier we had seen that if we have a vector A and we add a vector B to it, we get a new vector C. So you can take two vectors and just add them together, get the third vector. We could also go in the other direction, so that we take a vector C and we can break it up into two vectors, A and B. So if I take a vector A like this and B like this, then this A plus B is C. So C could be broken up into A and B. Or the same vector C could be broken up into this vector A and this vector B. And A plus B becomes C because they're following the tip to tail rule over here. So A plus B is C. So in other words, we can break C into any number of possible components, B and C, A and B. You can make an infinite combinations of A and B to get the C. Well, you could even break C into more than two vectors. You could break the vector C into vector A, a vector B, and a vector D. So C is now A plus B plus D. So you can break the vector C into any number of components. The useful components are what we call the rectangular components. And this is a very useful tool for writing a vector and also for adding and subtracting and doing a number of operations with vectors. So if I take my XY coordinate system, and if I have a vector here, that is my vector. Let's call this vector, call it C. And then this is my X and that's my Y. Then if I break it up into two vectors like this, A and B, but those vectors are, I drop a perpendicular here. One vector is this one and the other is this one. So these two are the components of C. You can call them A and B, but we prefer to call them CX and CY because this one is in the X direction and this one is in the Y direction. And then we can say that our vector C is CX plus CY, both vectors. Now, we should also have a good way of finding CX and CY, and we do. So if this angle is theta and the length of this vector is the magnitude of C, then we know that from trigonometry, CX over C, the magnitude of CX over the magnitude over C is cosine theta. And therefore, the magnitude of CX, okay, this is not the vector CX, it's the magnitude of CX, equals the magnitude of the vector C cosine theta. So since we knew the vector C, and that means we know its length and we know its angle, we know the value of CX. And similarly, CY over C, again magnitudes, is sine theta, which means CY is C sine theta. And again, this is the magnitude. We don't have that. Well, you can put that here because we're taking the magnitude. So this is the magnitude of CY, and that's the CX. So we have CX and CY. And then we can simply say that the vector C is CX C cos theta plus C sine theta. Okay, CX, C, that's CX and CY. So I just rewrote that equation. The difference between these two equations is that this is a vector and this is a scalar. but it must be a vector because scalar cannot become a vector. You have to have a direction. So we have to somehow say that this is, let's just put it like that, this is in the x direction and this is in the y direction. Or this is one way of doing it. It's not a good way, and we normally don't do it, but you have to have some way of saying that this is the x component and this is the y component, because you won't be writing the cosine and the sine, you just be putting in the numbers for that. So to do this, to indicate the direction, we have something extremely useful which is called the unit vector. A unit vector is a vector of magnitude 1, and it has some direction. Whatever is the direction is the direction of the unit vector. Now, you could have unit vector in any possible direction, but again there are three very useful unit vectors, and they are those which are in the x, y, and z directions. So if I have my coordinate system here, that's the x, y, and the z which is coming out of the page, then a unit vector in the x direction of length 1 and the direction is x. So that's one unit vector. A second unit vector is again of magnitude 1 and the direction is in the y, and a third would be in the z direction, again magnitude 1 and in the z direction. And because these are very specific, being in the x, y, and z directions, we have names for them. This vector is written as the vector I, this is written as the vector j, and this is written as the vector k. And then further, to indicate that these are unit vectors, we put the vector is written as a with an arrow or a with a line. These we write with what we call a hat. Okay, so the unit vector is written with a little hat. So whenever you see a vector, it doesn't have to be ijk, it could be something else. So if you see a vector e hat, it means it's a unit vector. Okay. We'll only talk in terms of I, j, and k unit vectors, but you could have a unit vector in any possible direction. Now, let's say we have a vector which is a force of 5 newtons in the x direction. So we can write this as 5 newtons x direction, but or at 0 degrees. But what we can also do is we take a unit vector I, which is length 1, and multiply with 5 newtons. So that makes it 5 times I newtons. What we've done is we took the vector of unit length, multiplied with 5, so it's 2, 3, 4, 5, so it became a vector of this length. The 5 becomes its magnitude. The I means it's in the positive x direction. Similarly, a vector that's purely in the y direction, so if we had 5 newtons at 90 degrees, well, we write it as 5j newtons. The j means that what you did is you took this vector of one length and multiplied with 5 and made it longer. Now, if you have a vector at any arbitrary angle, so let's say you have 5 newtons at 30 degrees. So how do we use the xy coordinates here, the I and j terms? So let's make a little diagram here. That's the x, that's the y. This is 5 newtons at 30 degrees. this is the x component, which is 5 cos theta, and this is the y component, which is 5 sine theta. So we can 5 is common to both, so we can write it as 5 cos theta I plus sine theta j. That will be our vector f. So 5 is the length, and cos theta I, we can take that out. So the I indicates this is the x component, the j indicates this in the j direction. And so the unit vector for f at, this is 30 degrees. 30 degrees is simply cos theta I sine theta j, which is cosine 30 I plus cosine 30 j, and cos 30 is 0.866 I plus sine sine 30 is 0.5 j. So this becomes the unit vector at 30 degrees. And what we've done here is we took our unit vector at 30 degrees and multiplied it by 5. Like here, we took the unit vector in the x direction, multiplied by 5. We took the unit vector at 30 degrees and multiplied by 5. Now this thing is used extensively, and we will write our vectors usually as a in terms of ax, which is a scalar, times I plus ay times a j. And ax will be the magnitude of a cos theta, and ay will be a sine theta. So if we have, for example, we have the when we go into the chapter on gravitation, we'll say that we have the Earth over here. Now let's say the moon is over here, and the Earth is pulling the moon exactly towards its center. So we want to find this force. Well, there's an equation for the force, and we already saw that earlier in as a part of a quiz number 1. That was G, mass of the Earth, mass of the moon, over the distance between the two, r squared. This distance from the center to center is r. But that's the magnitude of the force. And since we want to write the force, it's a vector, we would not only have the magnitude, which we get from here, but we need a direction. And the unit vector in this direction, pointing towards the Earth, is what we need to write over here. So how do we get this unit vector? Well, if this angle is, let's say, theta, this angle is also theta, and this whole angle becomes 180 plus theta. And therefore, this is, well, let's call that phi. So it's simply cosine phi of I plus sine phi of j. And this thing, cosine phi I plus sine phi j, is the unit vector pointing in this particular direction, in the direction of phi. And f is the magnitude, which comes from here. And then, well, you get the whole vector in terms of some fx, well, I and fyj. And incidentally, this term f times cosine phi is fx, and f times sine phi is fy. So they're sort of same thing written in a different way. Now, there's one more way of finding the unit vector, and that is this. We can start from here. Here we have this force is fxi plus fyj. So if I divide this, let's write this force as the magnitude of the force times the unit vector in that direction. So this would be the unit vector. This unit vector would be f, and that is fxi plus fyj. Then the unit vector f is going to be fx over the magnitude of f I fy over the magnitude of fj, and that's how we get the unit vector. Now fx over f is going to be simply cosine theta, and this, or phi, and that's simply going to be sine phi. So it's sine cos phi I plus sine phi j. But if you don't know the theta, you're just given the vector in this form, then you just divide the x component with the magnitude of f, the y component with the magnitude of y, I and j, and that gives you the unit vector in that direction. Okay, so that's what we have for vectors. Now there are solved problems in the on Canvas. You can have a look at them to get an idea of different kinds of solutions, and then, well, there may be some quizzes. Okay, so that's it.